In today's lesson, I'm going to talk about processes in the carbon cycle and the changes to those processes over time. This is part of the OCR A-level geography spec 1.C, and that relates to the area that I've highlighted there. So I'm going to talk first of all about photosynthesis. This happens in phytoplankton and it happens in trees, and it's the way in which plants use sunlight, they use water, and they use carbon dioxide, and they use this so they can create glucose, which is a form of carbohydrate, and they also form water. So eventually that glucose will be used by the plant as part of respiration to create energy. So it's in a really important process in the carbon cycle. When I adjust that equation slightly, I can get much higher rates of photosynthesis. So what I mean by this is, here's a phytoplankton bloom that occurs in the Arctic Ocean, and this only occurs when the amount of solar radiation increases. So in the Arctic in spring, solar radiation is much more concentrated in that area, and therefore there's more sunlight for the phytoplankton present in that surface ocean to actually bloom and grow. When I take away that solar concentration, so when the solar radiation is weaker in the winter months in the northern hemisphere, then that disappears and will only reappear again when the radiation is more concentrated next spring. Similarly, if I add more CO2 to the atmosphere, that will allow phytoplankton blooms to have more input to therefore bloom in greater size. And so we're seeing, as the global CO2 levels have increased, then there is more CO2 for those plants to grow, and therefore they're growing in numbers. And as we increase those global CO2 levels, we're seeing the melting of sea ice. And when there is the melting of sea ice, and we see this picture of a phytoplankton bloom in the Barents Sea, when there is more space for them to actually bloom, then we get bigger phytoplankton blooms occurring. So as time changes, as the temperatures go up and CO2 levels go up, we're probably going to see more phytoplankton blooms in the kind of areas such as the Arctic Ocean. The next process I want to consider is precipitation and the influence that carbon has on it. So carbon dioxide in the atmosphere, when it dissolves in rainwater, then that actually creates what we call a carbonic acid, a weak carbonic acid. And this can have a big impact in the carbon cycle. So as we are putting more CO2 into the atmosphere by burning fossil fuels from what we call anthropogenic carbon emissions, man-made, then that means that rainfall is going to have more carbon dissolving in it, and therefore is going to become more acidic. This then goes on to have knock-on effects on other parts of our system. So when precipitation gets more acidic, that obviously some of that will fall into the ocean, and therefore the surface ocean becomes more acidic. We call part of this ocean acidification. There's also the fact is, if there's more carbon dioxide in the atmosphere, then more of that is diffusing into the ocean, and therefore the dissolved carbon levels are rising in the ocean. When we get more dissolved carbon in the ocean, what this actually causes a problem is that the marine life in there, so clams and the kind of coral that we discussed, which uses calcium carbonate to build its shells, well, it actually can't do that as well. It can't build its strays of song because the ocean is more acidic, and therefore it grows weaker shells but smaller shells. And when these marine life were weaker and smaller, then less of that actual carbon that they would eventually transfer down into the deeper ocean, then less of it gets down there. So it affects our kind of carbon cycle in that way. I'm now going to talk about respiration. Respiration it happens both in animals and humans. And the key idea is that, as I said before, it's how they create energy. So they take those carbohydrates they've created through photosynthesis, so that glucose, and then it gets they take in oxygen, which causes that carbohydrates to burn and give them energy. So it's different to photosynthesis, and the formula is that glucose and oxygen put together, that creates and releases carbon dioxide back into the atmosphere, as well as water, and creating energy. Next we have weathering, which is the breakdown of rock in situ, so that means without movement, and obviously carbon can have a big impact on that. If I have that carbonic acid in rainwater, then when that rains onto certain rocks like limestone and chalk, then it will chemically weather that, and we create the kind of patterns that we see here on this limestone pavement in Yorkshire, where we can see the acid has actually cut into the rock. Obviously, we're talking about changes over time, and so when I have more acidic rainwater, and this is again because more CO2 which is dissolved into the rainwater, then I'm going to get faster chemical reactions. So we can have a real impact on chemical weathering depending on changes in the carbon cycle over time. It's also, we can have changes in terms of biological weathering. So biological weathering is caused partly by the growth of trees and the way that their roots interact. And so if I have more CO2, I get more CO2 for photosynthesis, which means I get more tree growth, which means I'm going to get more biological weathering. And an example here is this tree has actually grown so rapidly because it's got more CO2 available to it that it has actually been able to spread its roots into the rock, and that rock has been broken up by the increased growth of that tree. When those trees eventually come to the end of their life and die, we have another key process, which is that of decomposition. And here we can see some fungi that is actually breaking down that tree. And that's what the process of decomposition is. Fungi and bacteria breaking down the organic matter, in this case a tree, and by doing that, they release CO2. One thing that decomposers like fungi and bacteria love is they love the fact when it's warmer. They love warm, humid conditions. So if I add more CO2 to the atmosphere, and therefore I get warmer temperatures, then what's going to happen is I'm going to get faster rates of decomposition. The last process to consider in the carbon cycle is combustion. It's a scientific word essentially for burning, and it's when an organic material like a piece of wood reacts with oxygen, and by doing that it burns. So this can happen both naturally and through human causes. So naturally, an example would be if lightning starts, the spark of a lightning actually causes a forest to set alight. That would happen and you get wildfires. But you can also get combustion by the most obvious way is when we burn fossil fuels, so human activity. It can also be when a farmer decides to burn grasslands or forests, maybe to try and add nutrients to the soil. But this is essentially when humans have purposely done it. And combustion has a really important role to play in the carbon cycle, because here we see a graph of the atmospheric CO2 on Earth over the last 300,000 years, and we can see it kind of goes up and down, but in the last 200 years it has had a massive peak going up from 250 parts per million up to nearly 400. So combustion of fossil fuels is really a major reason for the massive increase in atmospheric CO2, and the fact it's happened mainly in the last 200 years because of human activity. And at the moment, current rates mean that 10 gigatons of CO2 are actually released into the atmosphere from burning fossil fuels. So that's a really significant part of the process. And obviously that, as we have shown in the other processes, has an impact on lots of the other processes going on in the carbon cycle.